Are aliens real? Expansion means replication. Last time, we estimated that roughly 3 dozen alien civilizations could share the Milky Way. But that number doesn't answer the question most people are asking. Are aliens real and could they actually be here? To find out, we need to look at how expansion really works. Whether we call it galactic colonization, self-replicating probes, or von Neumann machines, the principle is the same. Expansion means replication. In this video, we'll explore how replication drives the spread of alien civilizations, and why that process matters for Earth right now. Replication is a hard problem. Replication is the only way patterns spread, from molecules to machines to empires. But pushing through the stars requires an unbroken chain of colonization, and there's no formula that works on every world. A probe that thrives on one planet might fail completely on the next. If errors creep in, the system can even turn against itself. Colonies cannibalizing their own resources, or factions collapsing into civil war. Each new copy demands vast energy, rare materials, and constant redesign to meet the challenges of the next horizon. Expansion isn't smooth or inevitable. It's an opportunistic enterprise with hard limits. Expansion is more than replication speed. The simple way to ask if aliens are here is to plug in an average replication speed, maybe 1% the speed of light, 10% the speed of light, or something in between, and then see how fast an empire could sweep across the galaxy. But real expansion doesn't work like a smooth wave. The moment replicators meet others, there has to be a response: diplomacy, competition, or outright war. We already predicted in the Darwin filter that about 36 civilizations mastered replication, upgrading, and expansion. But success doesn't mean constant motion. That's why calculating a single speed won't tell us if they're here. Expansion isn't just physics, it's interaction, and those interactions decide the outcome. From chaos to a Cold War galaxy. In the early stages of galactic expansion, uneven encounters can lead to decisive victories. Stronger replicators overrunning weaker ones, or absorbing them entirely. But as empires grow larger, the rivals they meet are closer to equal strength. Conflicts in this phase are slower, harder to resolve, and often stretch across thousands of light years. Moving a border might take millions of years. Some frontiers freeze into stalemates, others stabilize into negotiated zones. The result is homeostasis, a Cold War balance where every power continues to plan for expansion, but true gains are rare and depend on extraordinary circumstances that may not occur for millions or even billions of years. The math says they are here. When we actually run the numbers, the expansion phase doesn't take long. Based on 3 different stages of expansion, a replicator can reach an empire radius of 8,300 light years, the predicted stability size from Part 2, in about 3.5 million years. If the galaxy was able to start life about 10 billion years ago, we predict that the rise, clash, and consolidation of empires likely happened around 7 billion years ago. Since then, the galaxy has been in relative stability for roughly 6 billion years. What this tells us is that the map of the galaxy is already drawn. The borders are old, the territories established, and Earth sits inside one of them. Which brings us to the final question: how many civilizations have real access to our planet today? How many have access to planet Earth? We use Earth history as a guide, and we start with one simplification: hex-style borders. That puts Earth in reach of 1 to 3 major empires, 1 if we're interior, up to 3 near a corner. A single great power can manage dozens of dependents across its map, but at any one theater that compresses to a handful. Expect 1 to 2 client states running the corridor, and 2 to 4 vassal operators handling local lanes. And you never get to 0 rogues. 1 to 2 pirate outfits persist in the cracks. Add it up, and you get roughly 5 to 11 distinct alien lineages with at-will access to this patch of the galaxy. In Part 4, we'll ask how advanced they are, and when we might actually detect them.